Alright, welcome to today's class, Fractional Calculus. My name is Sunday Oluwafemi Godogbe and I'll be your instructor. So today in our last lesson, we have able to derive a fractional derivatives for function x raised power n. So we are able to derive that the fractional derivative for x raised power n is n factorial over gamma n minus alpha plus 1 xn x raised power n minus alpha. So today we are going to implement this formula to solve two examples. The first one is if y equals to x, we will find the half derivatives. So let's go straight and implement that method. Alright, if y equals to x, then we need to know the value of n. Then we also need to know the value of alpha. So if we compare this and contrast this, we see that the power of x here is 1. So that means our n here is equals to 1. And we see that our alpha here is half. So alpha equals to half. So we substitute these two equations to our formula, and then we write the formula down here. We have the alpha, no bracket y, equals to n factorial over gamma n minus alpha plus 1 xn minus alpha. Alright, so let's substitute the value we have and let's see how the solution goes. So we have the alpha, our y, that is 1 over 2. So this our alpha is half, this is half, and our y, that is the function we want to derive, which is x. So our n is 1, so we have 1 factorial over gamma n, which is 1, alpha, which is half, and plus 1 x raised power n, which is 1, minus alpha, which is half. I believe you are following. So now we have 1 factorial, that is 1, over here we can have, that is root, and that is gamma 1 plus half, that is 3 and a half, or 1 and a half. 1 plus 1, 2 minus half, that gives us 1 and a half, which is x, and x is power, and this also gives us half. Alright, so this now we can just split this. We can deal with our gamma here separately. That will be 1. We can write it as gamma half plus 1, and half plus 1, that is 1 and a half. So we are still doing the same thing. So if we remember the properties of gamma functions, then we already recall that gamma x plus 1 is equals to x gamma x. So we substitute this here now. That means that we are going to have 1 over x. So our x here now is now half, that is half gamma half, gamma half x and the half. Also you will recall that in our gamma properties we have gamma alpha to be root pi, I believe you remember that. So we also substitute that back. Then we are going to have our the half x equals to 1 over 2 root pi x and the half. So if we simplify this further and properly, we are going to have 2 root x over root pi. That will be our solution for the fx. So you can see the beauty of fractional calculus. We have successfully solved that when y equals to x, then the half of it, the half derivative, give us this wonderful expression. And y the full derivative, the y dx, that will give us what? Yeah, that will give us 1. Alright, so that is that. So another example I want us to solve is, and the example is the constant. If y equals to constant, I know if you find the y dx, that will be 0, but let's see what the fractional derivative will give us. So here now we know that our y equals to c, and we can also write it as y equals to c x raised to the power 0. So that means our n here, that is the order of x's, is 0, and then our alpha here is half. So we can substitute these two into the equation, which is the half in the bracket our y, which is c, equals to n factorial, which is 0 factorial. These are formula here, so you can look at it as I'm substituting those values we have. And then we have gamma, our n, that is 0 minus alpha, which is half, plus 1. Then we have x raised to power n minus alpha, that is 0 minus alpha. Alright, and we know that 0 factorial will give us 1. So we have gamma 0 minus half plus 1, that is half. Good. And we have x raised to power minus half. So now if we find the gamma of half as we find earlier on, that is root pi, and we have x minus alpha. So if we simplify this according to law of indices, we are going to have 1 over root pi. Because of this negative power is going to drop down, that will give us root x, and that we can have 1 over root pi x. So this is the fractional derivative of a constant. But do you know that this does not satisfy the differentiable and the differentiable properties, the differentiable axioms? Because in differentiable, a function is differentiable if it is also continuous. But here, if x is equals to 0 at our derivatives, so we are going to have indefinite, we are going to have undefined function. So that gives us the limitation of this particular formula. So, and that is why we need to also check another formula in this fractional calculus. And in our next class, that will be our focus. In our next class, a better formula we can use to find fractional derivatives, whereby the differentiations properties will be satisfied. Any question, drop it at the comment section, and thank you for watching. See you in the next class. Thank you.